understand what different organizations at this point of time are challenges they are facing, what different teams that we work with they are facing on the field, and how they are leveraging data and AI to solve those problems. If in case you have any question, maybe we can take it at the end. You can, park your questions for now, or if you want, want to interrupt, just feel free to interrupt me as well. We'll take the question, or otherwise we'll take it at the end. Okay. So looking forward to our interactive session. Let me quickly share my screen. Shubham will have to give me rights to share.
Yes, yeah, we'll do that. David Sartak, just.
Sure.
Yeah, done.
Okay, thank you. Let me share my tab. Just let me know if you're able to see the screen. Is it visible?
Yes, sir, it is visible.
Okay, great. Let's get started. This is, though looks like a simple equation, but this is what I have learned from my a decade-old career, is both data as well as AI is something that drives innovation. It's neither only the data and nor only data science or AI or ML. It's both together, and that's what different customers or organizations are harnessing today, and we'll look into that. So let's start with the first module, which is understanding the data. Now, data, you must have heard, many a times from our, honorable Prime Minister as well. The data is the new oil. The data is the new gold. And even, a lot of leaders around us, you would see that data is the new power, or the data is the new, area that everyone wants to leverage. But what I would like to mention out here is data is also a strange currency. Why we say that? Because the way the currency works, the way you exchange the currencies, buy different things, you build economy. That is where the important aspects of any country or any organization, like they exchange currency and buy commodities, and they build their entire portfolio. They build their entire business case around it. Similarly, the data is that kind of a currency. Today, you would see there are a lot of different organizations which are utilizing data, and that's their business model. Google is one of that company. It's a data company altogether. If you look at different public domain, apps that we have, that Google is all that they're trying to identify is how the data can be made easily available to the customers, the information in all surrounding raw data that is present, how we can identify the right information and bring it to the user and use that kind of a data for their own business model. So though the data is ubiquitous, but it is really very valuable. And that's what I think as a freshers, as different upcoming engineers, we should understand that why we should need to pay more importance to data around us, harnessing those data, how we can relate this data to the business problems around us, or let's say which have not been solved yet. Moving on, data helps you create that kind of a competitive advantage that is well acknowledged. And why am I saying that? If you look at organizations today like Amazon, Flipkart, even in the e-commerce space, or a lot of financial organization, you must have heard about a lot of FSI customers coming up. They're trying to identify, okay, maybe look at Policy Bazaar, look at some of the FSI in terms of neo banks that have come up. All that they're trying to do is create a competitive edge based on what customers are looking for. If you even look at some of the groceries, what they're trying to do is get you the data, get you the groceries or whatever you orders you place in less than 10 minutes. And there has been a lot of competition on Swiggy, Grofers, and a lot of other companies in the same domain done so. What they're trying to leverage out there, or what is they're not selling something different. Okay, it is the same product that you would have been ordering, which would have been taking maybe a week long. Bringing that down to 10 minutes or 15 minutes or 20 minutes, it's basically the algorithms, it's basically the platform that they have built. The moment you place the order, how good is the system that moment an order is placed, my entire downstream systems, be it the inventory management, be it the supply chain, be it the delivery, how they are tied together that it just takes few seconds or few minutes for this data which you are kind of placing, the order that you are placing, to go downstream into each of these systems, and they start working with a lot of personalization in there. Then there are a lot of algorithms in order to reduce the overall time for any delivery person to reach your place. So there are a lot of algorithms that goes into supply chain, into reducing the overall distance, how different optimization can be done. There's a separate field that we call as OR, operational research, which goes into these kind of a problems. So it's actually the data and the data science on the top of it, which is creating a competitive edge for these kind of organizations. Now, let's see how this space has evolved. There are a lot of buzzwords that you will come across when you will first try and hear about big data. So there was something, if you look at maybe a decade or more than 15, 20 years ago, there used to be data warehouses, Teradata, and a lot of different kind of, Vertica, a lot of different Neteza, these kind of a data warehouses. There used to be a concept called data marts. Okay, that we are creating a data marts and anyone can go and access their own data, and it gives you a complete business intelligence reports and dashboards. This actually kind of moved into where people started to look at, rather than looking this as commodities, they're looking at as a more of a softwares. Okay, data warehouse appliances. Okay, can I go and plug and play a particular data warehouse? I get data from different sources, and I give you that kind of appliance to you. Similarly, from reporting and dashboard purposes, it moved on to relying on a marketing team to kind of drill down or crunch the dashboards for any organization. It moved on to how you can yourself discover the data, and more self-service, more democratization of data. Can I give it to any analyst to identify the particular data? Of course, taking into account the security and governance, but how I can give data in the hands of the users, rather than keeping them exposed. Okay, wait for 1 month, give your requirements, we'll create the dashboard for you, we'll come back. That's no more the case. It's more self-service and more self-discovery kind of a scenario. Now, because of these needs, what different other buzzwords that have come into play? Data lakes, very commonly. In my last company at Astro, when I went there, it was in Malaysia. It's a media entertainment giant out there. The first project that they were working on, and that's what I was heading, was data lake. We want to build a complete data lake. Okay, what is this data lake? We have heard about data platforms. We have heard about Hadoop, big data. What is this new thing called data lake? And this was like 5 years ago when I came across this. And now even data lake is an older one. Now we have something called data fabric, data as a service. So all of these buzzwords, they started to emerge. Streaming analytics, open source frameworks are there. Then machine learning has been there from last 10 years. It used to be something like, there are only few set of people who can go and work on machine learning. But now it is so easily available to every single developer out there that they can do and simply start using machine learning in just an hour. So and of course, the emergence of cloud data platforms. So 10 years back, I still remember we used to struggle with our Hadoop clusters, working on keeping them running, MapReduce and other things. We never thought about, what is cloud? How is cloud data going to help us? We just thought, we used to think, we have a data center, we have these machines, and we have to make sure that these big data systems are running properly. We never thought of agility. We never thought of scalability. That will there be a possibility that I can auto scale? I can add more machines on demand. It was really, used to be a nightmare at thinking that I have to add 10 machines on demand into my Hadoop cluster or any big data cluster, and it will simply happen on its own. So cloud actually came up with those concepts that you can run the similar systems with more agility, scalability, on demand kind of a concept. Now, this space has evolved too much. Now let's look at first the fundamental aspects before jumping on to different buzzwords and we just Google around, or search around saying what is data lake, what is streaming analytics, and get confused. let's go back to the drawing board and look at what is data engineering. So data engineering is very similar to what you will have civil engineering. Okay, in civil engineering, what happens? You must have seen a lot of buildings, being developed around you. We first get the raw materials. So the raw materials, like it could be iron rod, it could be bricks, it could be the sand and many other different concrete and different things that are need to be brought to the job site. So that's what similar is the case in building a data lake or data engineering. Is you bring the raw materials, which is nothing but your data sources. You try and identify, okay, where do I have a structured data with me? Where do I have a transactional data? Am I looking at a social media data? Am I looking at a marketing data? So all these different type of raw data sources that you have, they becomes your raw materials. Now, what is the next step? Of course, the next step important is that you transform those raw materials into useful forms. Let's take an example of wood. We used to get a lot of big, huge wood planks, and then there is a carpenter, and then there are machines who are cutting down this wood into actual blocks or logs of wood, or proper boards that can be utilized to build the rooms. Similarly, the raw materials on the construction side, you kind of create and change those bricks, cut them, put it into pieces, join multiple things together, and finally form a structure. So similar is the case with data. You have to build something called pipelines. You bring your data, which is in the raw format, depending upon what you're trying to build. Depending upon, let's say, I want to cleanse the data. I want to remove some noises within the data. I want to see that, okay, there are a lot of null values, let's say empty values out there. I want to remove those empty values. There are certain first name, last name, and I want to combine them into a given name. Or I want to convert a particular timestamp in a string variable into a proper timestamp column, so that that can be easily utilized. And there could be multiple such basic to complex transformations that you would do, just like you would do in a civil engineering scenario. Then there comes the third step. The new building is the new insight. So when we put all these things together, all the materials in the right transform phase, what we see is there's a building starts coming up. And that's what is equivalent in a data engineering scenario, is the insight. I've put everything into my data lake. I brought the raw materials. I performed the cleansing and transformations, put it into maybe a warehouse, and I'm trying to build a data mart or a data warehouse. And then I'm trying to identify insights from it, patterns from it. Let's say it could be related to a data which is like customers in e-commerce. We interact with e-commerce websites and produce a lot of data. So what the companies do is they try and look at your purchase history and identify, okay, what are the patterns? Nitin needs to shop a particular set of segment and certain categories. What has been the last time he ordered on our website? What last 10 orders have been which particular category? So they basically try and identify patterns out of it and kind of recommend me, so that next time I visit their website, they say that, okay, this is some of the categories you love or you have shopped in the past. You should try and look at some new items or entrants into these categories. So all this are different insights, and now those insights could be ML based, which is predictive, just like I told you an example of recommendation. They could also be insights which are descriptive in nature, which is like historically. I want to look at historically from a time series analysis, what has been the returns for a particular bank, how much losses they have seen, what is their debt, there could be multiple different factors. Even for any organization, how is the overall revenue working around? All of this would require data being captured from multiple places, like financials, their marketing, the cost, profits, and finally creating a dashboard out of it. So that is also something called an insight. So all of this is part of our stage 3. And then comes the last stage, where you are not just doing this once, you are trying to repeat the cycles. And in order to repeat the cycles, what we normally do is we do an automation. Even in when we are trying to create a simple application, or we're trying to do a task. Let's say let's not take a technical application. Even when we do a task at home, we first try maybe do something. We bring in different raw materials. We do some sort of working on the top of it, and finally there is a product being created, and then we start repeating that cycles. So that repetition or that automation is called orchestration in data. So you basically create an orchestration, just like a supervisor. It basically directs all the different aspects of the team. So the orchestration or the automation in data is going to orchestrate or automate each and every step, right from getting raw materials to transform the data to finally creating insights out of it. So this was a basic understanding of how the data engineering works. Now let's look at those specific buzzwords that I was talking about. Data lake. So first of all, very simple, very commonly you are going to hear when you are going to study on big data. What is data lake? So data lake, one, it is a scalable and secure data platform that allow enterprises to ingest, store, process, analyze any type or volume information. So there are a lot of things out here. So first thing that you look at is different type or volume of data. So what is type of data? So there are basically at a high level three types of data. One is a structured data, one is semi-structured data, and one is unstructured data. So structured data, a simple example is bank statements, for example, or any sort of KYC information that you have. These all are structured in nature. Or let's say a catalog of a particular e-commerce website. They're all structured data. What is the semi-structured data? Semi-structured data is like it's a structured, but it is sparsely located. For example, let's say this is more of a data in form of JSON or CSV. Let's say it's a blog website. Okay, it may not be that every single person is blogging on that website. There could be some people who are blogging, some people who are doing some sort of a comments. So it's not a proper uniformly distributed data. So if you look at the representation of that data, it could be that one person is doing 5 different things while the other person is doing 2 different things. So it is kind of structured, but it is sparse. It is not uniform distribution. Third type of data is completely unstructured. Let's say audio files, the music that we listen, the videos that you see on YouTube or many other video platforms, all this is unstructured content. Or let's say there is a different type of images that we come across. A lot of images on the web, they all are unstructured data. So first of all, first important trait of a data lake is that you can analyze any type of data. So you can bring in either a structured or a semi-structured or unstructured data. Second aspect comes is the volume of data. Any volume of data. So what do you mean by volume? Volume means the amount, the speed or the rate at which a data is coming to a system. Now, it could be a batch. What do we mean by batches? Let's say, there could be a person who's working in a bank and he has a lot of accounts to open. And what they normally do is, okay, let me collect all the different forms from morning to evening. And the next day, the person is going to work on that particular bundle of forms. So that's a batch work that they are doing. It could be other way around. Let's see, the moment an application comes, I want the person should immediately act upon that application and open the account. Similarly, there would be any other application comes in, the person who is idle, he should be able to work on that. So that's a streaming way. It's an on-demand way. So a data lake should be a way that it should be able to handle any type of volume. If I have a batch work to do, it should be able to do a batch work. If there is a streaming or a on-demand or a online on-demand work required, so it should be able to do that in an on-demand way. So any data coming in any form or any volume, the data lake should be able to ingest that. Other part comes in is the scalability aspects of it, is the security aspects of it. So scalability says that as my data grows, my data lake should be able to also grow or have more infrastructure. Now, where is this infrastructure? So your infrastructure could be on-premise, where you have secured a particular machine with you. Like, for example, this laptop is nothing but an on-premise for me. I can store something in my laptop. Similarly, you would have your own machines. Now, if you go a little bigger, in your, let's say, college, you might have 2 or 3 servers, which someone has dedicatedly bought and kept it into the college. So that's more of a on-premise setup. And this you can imagine, into a large data centers where you have multiply this by 100 or 1,000 or, more than folds, it will be a big on-premise data center. Cloud, on the other hand, is very much similar to an on-prem. It's just that there is an abstraction on the top. Think of it like I am going on a website like Google Colab, and I'm going to, or maybe a TensorFlow, anything. They have just, for example, very easy, let's say talk about a JavaScript fiddler. Okay, I can go into any website called JavaScript and I can go and test my JavaScript code. I am not procuring or not keeping a machine. I'm not installing anything. That particular website is giving me an abstraction layer to test your code or to build something. And I don't have to actually procure a machine. So that's the way of where the cloud works. You don't have to go into buying a machine. We are going to give you the resources or the capabilities that you need. Just use that. And then there are a lot of nuances within that called infrastructure as a service. There is platform as a service that and software as a service that I will ask you to go and look for it. That how different these services kind of as a service options available. Third is the edge. So what we normally call as edge computing nowadays very commonly being used is with Internet of Things. And where do you see all this Internet of Things? A lot of sensors. Nowadays, if you look at your car comes with a lot of sensors installed. Your vehicles, they have their sensors involved. There could be sensors, around when you walk outside, like a traffic sensor. It could be even sensors on sort of cameras being installed. So all of this, they have some computing power at the location where it is installed. For example, in vehicle, there is a computing power out there. For example, someone is not wearing a belt, it immediately alerts you saying that, okay, I could not see that there is a logged in seat belt. So that's a edge computing. It basically looked at, okay, there is a person sitting, but the belt is not attached, so I should go and immediately give a sensor. So there is a small edge computing happening at that point. And similarly is the case with when you have cameras in traffic. They basically take your photos and identify, if there is any, or what are the traffic going on, is there a congestion out there, then I can go and alert something. So those are examples of edge computing. So a data lake, basically what it says that you should be able to process any type of data with any volume. You can ingest it, store it for a longer time, process and analyze it, but at the same time also have a more scalable and secure data platform. So that I am able to basically use it on any particular infrastructure. I can scale it depending upon the growth of my data, and I can use it for any purposes, like using a SQL, you can do analysis, or maybe do a predictive modeling on the top of it, or just do a plain simple search. So that's what data lake comprises of. Now, what does data lake brings together? So data lake basically tries and brings together different types of raw data. So I've already given some examples, right? Raw data could be in RDBMS data. Let's say RDBMS, by which we mean is a database management system. Let's say we have an account with a bank and they store all the transactions in an RDBMS. So there could be a data which is the financial related. There could be spreadsheets. A lot of marketing advertisements data. Someone has created some spreadsheets. Okay, we are going to target these particular customers, or we want to create ads of these many products. So there could be a lot of data which are there in spreadsheets, and it could be some offline files. It could be some apps. So all of this together forms your different raw data sources, and you replicate your data. So basically, those data sources are having data at their end, but in order to unify my analytics and also decouple, I cannot always go and run my analysis in that system. Why I can't do that? Though it is possible, but think of it, there are 5 systems in a financial banking. There could be one which is taking care of all the transactions that you're doing. The other is taking care of all the KYC aspects, could be spreadsheets. The another is taking care of the APIs that they are working with RBI and many other financial institutions and those systems. If we go and run analysis in every single system, we are going to add more load on that particular system. So in order to avoid that load, and that system could go down, in order to have continuity, what we say that let's bring the data from those systems, replicate or means copy it into a separate system which is decoupled, so that it does not put any load on the source system. I can easily run analytics at the back end. That is what the data lake says. Okay, so what are the key considerations when you build a data? I don't want to go into too much detail, but just think of it. You've understood what is the basic definition of a data lake, why it is being used, and what an important consideration is, can your data lake handle all types of data? So you remember we talked about different types of data. Can it scale to meet the demand? As my data grows, do I need to do some manual activity add more machines, or I can automate, or it can automatically scale up to meet my demand and scale down as the data lowers, which is normally not the case. Data is ever growing, but you need to prune the data. That's an important thing. Just take out the important data, which is going to make sense, and you can maybe basically archive the unimportant data or maybe delete. Does it support high throughput ingestion, which is talking about the volume aspects? So when a high volume of data comes in, is it able to ingest that, or is it able to say no, or throttle, as we say, no, I'm not able to enter or ingest this kind of a high amount of data? Similarly, is there a find in access control? What do you mean by that? Is when you have data stored in your data lakes, who all can access that data? Can I go and have a restriction at the entire bucket level, or at each and every data level, or at each and every row level? So those are access controls. And how I can utilize this data? Can I connect some other tools to connect to get the data out from the data lake when I'm trying to analyze it? Or do I have to use the tools which are available within the data lake? So what is the overall capabilities my data lake gives me, so that, for example, I come up with any other open source tool and I want to basically analyze this data? So this is the different considerations that we have. Now, another concept that comes is the data warehouse. So data warehouse, basically, it stores transform data in a useful condition or a usable condition for business insights. We have a raw data. We replicate that raw data from different sources into a data lake. Data lake, we cleanse the data, and finally extract the data, transform the data based on our needs. For example, let's say I want to understand the overall what is the overall revenue from last 1 year. So what I'm going to do is just extract that particular relevant data, which is related to my cost, which is related to my income, profit for an organization, and just put it into a data warehouse in the form that is usable for calculating. So that's how, what we say, that we basically extract, transform the data and load it into another system called data warehouse, where you then run the business insights. Now, what are the key considerations in the data warehouse? So let's look at those considerations. So data warehouse is nothing but, I would say, it's kind of a subset of this entire data lake, which is having structured representation of your data. Data warehouses generally deal with structured and semi-structured. You will not see data warehouses being used for unstructured data like images or audio or videos. They are basically used for structured and semi-structured data. But one important aspect that you would see the difference between a data lake and a data warehouse is data warehouse has a more cleansed, more transformed form of your data, which can be used for calculating any insights. What are the considerations that we see in the data warehouse? Can it serve as a sink for both batch and streaming data? So we looked at the volume. The data could be coming in batches, it could be coming in streams, immediately on demand. So can it handle, can it ingest both the kind of data? Can it, again, the scalability becomes a question. Can the data be organized? So can I put it into multiple different tables, multiple different views, or let's say groups, so that I can kind of use that data or aggregate that data? Let's say I want to calculate what is my monthly revenue. So what I'm doing is I'm aggregating it on a month basis, doing some sort of a sum or maybe other calculations, and I'm giving a final value. Is the warehouse designed for performance? Can I scale this warehouse as the data grows? So all of the similar questions that you would see on a data lake would also come on a data warehouse. Okay, so you must have come across, or you may come across, this kind of a terminologies, which is extract, load, and transform, and there are different combinations of it. Which is the one which is more preferred? So one is a simple extract and load. What do you mean by extract and load? I extract the data, or basically take out the data from one system, which is my source, and I load it into my sync system. In between, I'm not doing any changes to that data. This is normally nowadays not being used because it kind of creates a duplicate copy. If you're not pruning the data and you're just extracting and loading it, it may not help. There is a better version of it, which we call extract, load, and transform. I extract my data, put it into a data lake, and then, or maybe a data warehouse, and then I'm transforming that data, which means I'm cleansing it, I'm processing it, I'm aggregating it. I'm trying to do some sort of some useful aspects. I'm trying to identify some useful data out of it by applying certain rules or conditions. On other phenomena is where or a process is which we have been used for many years is called ETL. Extract, first transform the data, and then load it. Nowadays, you will see a lot of companies using ELT over ETL. Reason being, uh, the potential of data is very unknown. There could be multiple different insights out of the data that you may not be sure at the first end before loading that data. So you basically say that, okay, let me load this data, let me bring all the source data, put it into my lake, and then I do a transformation in order to identify insights. I cannot transform it on the fly when I'm trying to load it and then decide that which is the data. So I better go with the ELT approach. But at the same time, in many systems where you are already sure that, okay, this is the transformation I want to do, you can adopt a ETL approach. So just at a high level, I wanted to let you know. Now, data warehouse themselves are not the use cases. Just remember this. And this is many organizations, many teams, when you will work with data, many times the ultimate goal of a company becomes, okay, I want to create a data warehouse, which is called enterprise data warehouse, and I want to use it for different purposes. That's not the end use case. The end use case is to generate insights out of it. Data warehouse is just a medium for you to give a better representation of your data, of your cleansed data, and then use different techniques on the top of it to basically calculate insights. Now, those techniques could be visualization, it could be creating any reports, or be it could be machine learning. We'll talk about this in detail. What are the differences between machine learning? But at a high level, a larger circle is the AI, which is this lot of set of techniques. Machine learning is the techniques to achieve or solve AI problems, and deep learning is one special machine learning technique which kind of solves the AI problem at a different with a different way, which is we call as neural networks, and we'll talk about that. It's basically more adaptable to unstructured data. Now, I think by now you must have understood what is the difference between a data lake and a data warehouse. So data lake captures every aspect of your data, the raw format, bring the data into one place. Why we bring it? So that we decouple it from the source systems. It should be able to support different data types, different volumes of data. So what we call this kind of a data is schema on read, because we are able to bring any kind of data, structured, unstructured, semi-structured. So there is no one single fixed schema when we are inserting data into data lake. But when we are reading the data, we kind of give a schema. Whereas when we go to a data warehouse, we only load a certain subset of data into data warehouse. So it's a schema on write, as we say it, where we are processing, transforming the data, putting into a data warehouse, more structured representation, historical data analysis for reporting. So that's where you are able to find faster insights. As I said, data warehouse is a subset of this entire data platform, which may have a data lake in front of it. Okay, so now that we have understood a lot many things on data, let me see if we have any questions before I move on to the next module. Okay, how to start learning AI. We'll cover that. Let me, I had some query regarding TS. Okay, let's take it. Let me just address this module and then we can take it. Shivang, you want to say something?
No, sir. I would request, yeah, show it. You can ask the question. Go ahead.
Okay, go ahead.
First of all, sir, thank you, sir, for coming in this. It was a really well session for a student like me who is learning data science. So, sir, actually, I want to ask, like, for a fresh grad student like me who want to pursue his career in data science, or just to or just have an intern in data science, what ideal data science project should I have in my resume, so that I could get short listed for the interview round. सर मतलब क्या कहते हैं हम उसके लिए अप्लाई करते हैं तो पहले रेफरल
Yeah.
वाला वो स्क्रीनिंग राउंड होता है सर, तो वो कैसे मतलब पार हो
See,
पाएगा?
I understood your question. At a high level, there are some basic techniques that you would have to understand and learn first. I know the main goal for any candidate at this point of time is to crack the interviews. But what I would suggest at this point of time, just hold on to your thought, understand the fundamentals around the data and the AI, and then you will be able to see in the next section that how this applies to certain business problems, and then you can pick and choose which particular problem I want to solve and prepare accordingly. So just hold on to that thought, and I'll cover that aspect as well.
Okay, sir.
Okay, so let me move on, and I'll take and come back to the questions. I think a lot of questions will be answered after this particular module on machine learning. So by now, everyone would have understand, okay, what is the data? How does it relates to my civil engineering? What is the data engineering? What different steps it have? Some two buzzwords around or terminologies called data lake and data warehouse. What is ETL versus ELT? So some basic concepts that I've tried to clear. Now let's look at machine learning. We've understood the data has reached my data lake or a data warehouse, a storage system. Now, how do I calculate or run some algorithms on the top of it to solve some of my problems? But before that, let's understand where is ML around it. So right from ordering food to shopping to booking tickets, file your IT returns, there is ML everywhere. When you order your food, as I said, there is recommendations. There are personalized offers being given to you. There are some pop-ups coming saying that go ahead, you can buy this based on what you bought earlier. You would see sections when you watch videos on YouTube that okay, these were some of the recently viewed ones, or these are some of the ones we suggest you based on your last watched history. When you try and book tickets, at the same time also you try and look at what are the rolling offers going on. The booking is being done so there are a lot of ML involved there. When you file your IT returns, not for your scenario, but even in a lot of financial and KYC related aspects, there is a lot of ML involved. Very common when you converse with any assistant, be it Google Assistant, Alexa, and others, or what different machine learning is happening. Just think of it, when you speak to an assistant, your speech is being converted into text. That text is now then being analyzed, as you called as NLP, natural language processing. You basically first, there's of course speech to text is a different problem. You're converting audio into text. Then that text has to be properly analyzed and looked for what is that you are looking for. Let's say I ask, hey Google, play a song for me. First, they will have to, I could have a different dialect. I could have a different accent. First, they will have to understand where I'm coming from, what is I'm speaking, then analyze the important aspects out of it. Play a song. So what I'm looking for, action as play, and what is the entity is a song. Now, based on that, it is going to apply and invoke certain APIs saying that, okay, which is the particular integration? Should I, start it from Spotify or should I start it from YouTube? And this is I'm going to play. If in case I don't have enough information, let's say I want to ask, can you let me know the name of the song? So it is going to ask you. So all of this that is happening, there is ML at the back end. Similarly, when you do search for locations, you are at a particular place and you're looking for a location. It gives you a complete directional map that okay, this is the way you should follow. This you have 5 different alternatives. All that is doing is machine learning at the back end, identifying on the real time where is the traffic, where is not the traffic, which alternative would work better for you, how much would be the distance from your location. So a lot of geolocation and geocoding goes into it, and all of this has a lot of machine learning involved. Trading, of course, in stock markets, financial transactions, this everything they have machine learning working here. Now, look at a little brief history of machine learning. So in 1942, a neurophysiologist, Warren McColl, and a mathematician, Walter Pitts, they basically wrote a paper on how human neurons might work. So this becomes a kind of a baseline for a neural network. And I'll talk about what is neural network in the upcoming slides. 1950, this is very well known from a scientist called Alan Turing. He created something called a Turing test. to determine if computer has real intelligence or not. So basically, a human used to speak with the computer, but human is not knowing that he's speaking to a computer. He's just doing a phone call and or calling something and just asking. If human is able to believe that he's talking to a human, then the computer is able to succeed. So Alan Turing test has passed. So that was one way of doing some sort of a kind of a foundational aspects to machine learning, that how human can mimic or basically do what how computer is able to do something that a human is doing. That was very basic, and a lot of things has happened since then. Now if you look at in the last 10 years, you've heard about in 2010 Google working on self-driving cars. Tesla already has one self-driving car already there, and there are a lot many other companies who are working on the same. IBM Watson, which is now owned by IBM, they wins a competition where a computer is able to solve all the problems. Even the games, from chess to AlphaGo, even Google's artificial intelligence algorithm was able to beat a particular a human on the chess aspects. So whether it's robotics, whether it is vehicles, plants, machinery, there is ML that has been there in last 10 years everywhere. Now, how this has further matured. So if you look at it, and this is what I mean by a neural network, let's keep the neural network aside and think of it, this picture. When you look at a picture, what happens is you try and look for certain features of that picture. If you look at a dog, what you would normally look at, what is the face looks like? Does it have a tail? Does it looks like, does it has any mustache and anything? What are the eyes? How is the ears? And you try and look for those features in differentiating whether it's a cat or a dog, right? Similarly, and what is happening when we're doing this, we are stimulating our brain neurons. So we try and look at, there is an eyes, create a stimulation, it basically goes and sends a response to my brain, and then there are a lot of things that happen, and finally we come to a conclusion, yes, no, it is not a cat, looks like a dog. There is a dog collar out there. So there are all different things that I'm trying to identify is nothing but the features in that image. The similar thing is what the neural network is doing today. It is exactly trying to mimic a human behavior, where I start with certain inputs, and then I do some sort of a neurons in between. I stimulate some neurons. There are complex mathematical equations in between, which finally decide, first of all, train a model and gives out an output that, okay, this is a dog. So that's how basically a neural network works at a high level. I'll not go into detail. We'll look into it, these aspects at a later stage. Now, look at this particular GIF. In 2015, this is something, a video basically of a transform from a self-driven car. So if you look at, this is the actual video and what it is transforming to. What it is doing, it has color-coded different objects coming in front of it. Whether it's a sign symbol, whether it's a pavement, it's a road marking, it's a sky, and what. And then it is applying rules on the fly that, okay, these are particular objects, which is fine. If something else comes in, then I have to stop. This further matured in 2017, 2 years ago, into this kind of a 3D model, where now if you see, it is not just using color coding, it has given a 3D depth also. Now they're able to identify, okay, what is a car, which is a person, which is in red, and I should pause for that person, which is a car coming. So the color coding is there, but there is a more polygonal, or I would say 3D aspect. Now let's look at this particular video from how the Tesla autopilot works. Now, if you look at more than the video, it has taken into account multiple different aspects. Where is the red light? What is the coordinates of it? What are different coordinates and bounding boxes, of a particular object? Which is right? Which is not right? Where all different coordinations are going on. So this is a very good video which tells you about how the maturity of the machine learning has gone. 2018, we have seen a lot of apps coming up. You can replace your background. Okay, you can change try-on apps that you would see on a lot of beauty websites or even on YouTube and other areas. Can I go and change my hair color? Can I go and change lip sync That's also one of the apps. So a lot of this is what is doing. It's doing machine learning at the back end, but a lot on unstructured data. The structured data things that we looked at initially from machine learning, where it is able to do a lot of calculations and on the top of it. Now when we are dealing with audio files, video files, images, live video feed, this is all we are talking about, the unstructured content. Okay, so let's kind of move on. Okay, so just like we draw an analogy of data engineering with civil engineering, very easy way to understand machine learning is cooking. When we start cooking a particular recipe, what we first do is we get our data. And that data could be all mixed up. There are onion, there's potato, there's many other vegetables. What we first thing that we do is we pick up some of the raw data, some of the raw ingredients, and we clean that data. We basically clean it, explore, okay, which are the ones I need, remove some sort of items which I don't need, clean it. So that's what is very similar to, you get the data and you basically explore the data. Okay, what is the data I need? I need to clean the data, maybe remove certain columns or features which I don't need. Those are some of the ingredients I don't need at all. And finally, the next step is you select your cooking method. Whether I want to do a deep frying, I want to do a saute, I want to do a shallow frying. Similarly, you select your algorithm. Do I want to do a classification? Do I want to do a categorization? Or I want to do any sort of a forecasting? Or I want to do any recommendation? So I basically identify the algorithm. The next step in that front is, when you're doing a cooking, you basically now have you identified the algorithm, you have the data and ingredients. Now you basically cut them into right shape so that it can be used in the recipe. We call this as a concept called feature engineering or feature cleansing, where you basically clean the data into the appropriate formats. That, let's say I want to convert it into an aggregation, or I want to calculate what is the similarity between them, or I want to calculate what is the feature scoring. So a lot of scores that I give it to those features. So all of this tuning that we are doing basically, or basically cutting down the data into the right piece and right shape, is very much similar when you do a cooking and you cut your ingredients. Now you start creating your recipe. That is what we call as training the model. We have data in place, we clean the data, we identified the algorithm, we basically did a feature engineering on converting the data into the formats that I need, and finally I start training my model, or I start preparing my recipe. Now, after you prepare a recipe, you basically taste it. You say that, okay, does it lacking something? Similarly, your model is also something we evaluate it and look at, okay, is it, how is the accuracy? How much is the error in that? Can I go and reduce the error? So basically you test your model for best accuracy. Similarly, you test your recipe. Now this comes a repetitive phase where you keep evaluating your model by changing some of, you might change, okay, in a recipe, next time when you create that recipe, what will you do it? You will try to change the ingredients, add more ingredients, or you will try, shall I change the algorithm? Or shall I do some in my training process or in my entire cooking process, shall I go and change something else? Or let's say, I add another process. Let's say I should first, before doing a deep frying, can I go and simply saute them, put it some time on the shelf with adding some salt in it? So all are different techniques. Similarly, on ML, what you do is you either add more features, just like adding more ingredients, or I want to change my algorithm. That, okay, no, I was using a particular decision tree. No, I should know, I go to look at logistic regression, maybe some other ways. And many a times you also even do other different aspects. We call this parameters and hyperparameters. When you look at deep learning, parameters are like you add more weights and biases. Hyperparameters are like I add more hidden layers in between. So similarly, you make changes either into the data or my training process. Similarly, for cooking, you either change the ingredients, add more ingredients, cut down ingredients, and change your cooking process. And finally, when the model is ready, finally, when the dish is ready, you serve it to the customers or serve it to your family. Similarly, the model is ready, you basically serve it to the stakeholders whom you are working with. And you keep doing this activity again and again. By when you keep cooking, what you get is more expertise. Similarly, you have keep training your model and you get better accuracy. So that's a simple analogy with cooking and machine learning. I hope it makes you understand different stages of machine learning. Now let's look at what are different machine learning approaches at a high level. So one is a supervised learning, other is an unsupervised learning, and third is a reinforcement. Supervisors, as you can see in the image, someone is trying to help you. So you already have some data with you, which is by default labeled, and you use it for doing any. So let's say I already have I want to do a demand forecasting. I want to I forecast what is the demand of my inventory for next 3 months based on the 5 years historical data. So that historical data that I have becomes some sort of a supervised or training data set. And then based on that, I want to predict something, saying in the next 3 months, how much the demand I am going to see. Similarly, I want to categorize something. Let's say I already have a catalog of products. It is already assigned into some categories. Now a new product inventory comes in and I want to understand where this goes into. Say if I already have a catalog, I can use it to train my model. And as the new item comes in, I can have the model predict that, okay, this should go into this particular category. So this is a supervised learning approach where I already have some sort of a training or a labeled data set in front of me. Second approach is called unsupervised learning, where I don't have any prehistoric data. What I will have to do is, just like this child, if you give them blocks, they will try and create different patterns out of that blocks. So that is a very good example of a unsupervised learning. Like one example is clustering, segmentation. Let's say, I have multiple different customers in a particular location, and I just know what has been their average price or average order amount, and I want to calculate. I want to identify patterns that which in a location, which particular city I see customers which are having greater than 5,000 as the average order size. What I'm trying to do is plot that data and trying to identify the patterns which is the closest to the goal I have. So this is all some sort of a clustering approach, as we call it, and it is more unsupervised because there is no sort of a labeled data set or any sort of a already prehistoric data set that can help me reach my goal. Last part of learning is called reinforcement learning, normally used in game designs. This is the learning of penalties and rewards. Just like you see a grading sheet out here, what happens is if you do a right stuff, if you answer it correctly, you get a high grade, or you get marks for that. If you answer it incorrectly, what will happen? You will get some negative marks for it. So similarly, in a game design model, based upon how we approach, or let's say a maze problem, I want to identify the path. So those use reinforcement learning based on the penalty and rewards as you go and approach a problem. So again, this is not supervised. This is neither unsupervised. This is more with respect to what is the overall approach to the problem, and what are the different penalties and rewards, and basically adjust and identifies the right path. Okay, so at a high level, this is what I already mentioned, and many different engineers, even till today, who are kind of very experienced, they also kind of face this problem, and they say that, oh no, deep learning is a different type of thing, as it's an AI technique. Machine learning is different. No. AI is basically at a high level a technique which enables machine to mimic human behavior. Machine learning is nothing but a subset of AI using statistical models, statistical techniques, mathematical techniques to enable machines to approach or basically reach that AI goal or mimic human behavior. Deep learning is an advanced subset of machine learning where we are using neural networks to solve the similar problems. Just like I showed you, a cat and a dog, there are multiple neurons, multiple layers. You look at features. That's how a neural network works. And there are multiple different types of neural networks, which you can go into detail at a later stage, wide neural networks, deep neural networks. So AI thought leadership from Google, there has been a lot of, we already know, and if you're not knowing, then there are a lot of libraries that Google has open source, like TensorFlow, very well known in this regard, ML kits, DeepMind. There are not many things that Google has been doing in this open source space, and not just ML. A lot have done in the data space. A lot of white papers have been released, a Google file system that went into something called Hadoop or HDFS. MapReduce, they came up with a white paper that was the Hadoop that was created, and a lot of things like Dremel went into something called Impala. There has been Apache Beam, which is now heavily used across the industry for pipelines, data pipelines. So there is a lot of work that Google has done in this regard. Now let's come to a last module, and then we will open for questions, is the use cases and the solutions. We have understood importance of data. We've understood what importance of machine learning. We have analogies to understand data and machine learning, different stages in data, different keywords, similarly different keywords in machine learning, supervised, unsupervised, reinforcement learning, how machine learning relates to how different use cases we are solving, what kind of data it caters to. Now use this both of things to look at what are the real life problems that organizations are solving. But before that, what are organization or any team? Just don't think about, I'm talking about organization. Tomorrow you are going to be a part of a team which is working on a particular problem. What is your team and an organization looking at? They are looking at a black box where I'm ingesting a data stream. That box is doing some processing and some magic, and I am able to get the competitive advantage. This is a bird eye view what our organization looks at. But these are some of the complex things. How do I build this kind of an intelligent bot, intelligent black box, where I'm able to ingest the data, I'm very able to quickly process the data, and I am applying AI on the top of it, and I'm creating some sort of an innovation. This is the area which many organizations struggle with. When I was talking about 10 minutes delivery, just think of it. Data coming at a stream ingestion, going into, it is getting processed at the same time, it is targeting multiple different systems. There is AI which is happening there. There are different automation problems that are running. And finally, it comes out with, okay, this is this particular store, the inventory should be picked from, this delivery person should be allocated this particular work. He's in that particular vicinity at this point of time. So that's how they are solving this entire problem, and that's a competitive advantage they're trying to build. Now, where are organizations in the journey? So there could be, what is the maturity of an organization or a team? They could be nascent explorers saying that, we have data, we have been working for so many decades, we are applications, but we are exploring what kind of data that we have and how much of this can be used for insights. While there could be someone in the middle which is heavily invested. I have made a lot of investments. I have created data lakes. I've created data warehouses. But right now, I'm not too sure how to generate insights from it. Or I have a BI, business intelligence reports and dashboards, but I don't know how to basically maybe take it to the next level of machine learning. On the third hand, there could be organizations or teams which have very smartly thought from the right foundation days that we are not just going to build an application or a product, but at the same time, we also have to look what data I am generating out of that product. And can I use that data in the early days, start harnessing it, start using it, apply some algorithms, and create product innovations, which can be, again, or innovations which can be clubbed to my product, and that becomes a competitive advantage. So depending upon where you are, you have to look at what is the maturity and the end goal that you want to achieve, or other next problem or complexity or challenge that organizations face. In order to reach from one place to another where you have data, there are a lot of systems in place, a lot of frameworks, a lot of libraries. Should I go for a SQL? Should I go for a data warehouse like Teradata? Should I use a MongoDB? Should I go for a Spark? Or everything can be done using Spark? Or how do I reach to machine learning? So there are multiple pathways. Not the teams, nor organizations are completely sure. Many of the organizations. Next challenge that we look at is the data, type of data. It is not 10 years old back when we were just mostly dealing with structured data. There is a lot of unstructured content out there which has surpassed even the structured content. 90% of entire world data, and this is sort of a survey. 90% of the entire data that we have is unstructured, and it is still not being only 10% of that 90% is properly harnessed by the application or by the organizations. Lot of images, audios, videos that we have out there. It's much more than the structured data that you have. So again, the complexity is high. So you have challenges, organization have challenges in terms of skills. How do we create this kind of innovation? They have problems, challenges with maturity, that what are my goals? Am I looking at data? Am I innovating it from the start? Or I'm just looking at and seeing that, okay, what's to do next? There are challenges in terms of execution, a lot of frameworks, a lot of libraries. There is challenges in terms of the data that further kind of adds another dimension to it. Finally, what we look at the real business problems that different industries are solving together and addressing all these challenges. And we'll see in the next slide how they're addressing it. But what are the different use cases? We need to understand. From a retail standpoint, I want to optimize my prices. If I'm going to give a better price point to my user, of course, they tends to buy more. Can I have more personalization? Can I have a better recommendation system so that moment the user comes onto my website, they do not have to struggle in identifying the options. They have everything in front of them. Okay, go ahead. You were buying this previously. You browse this. Why don't you go ahead and buy? There's an offer. A lot of help. Demand forecasting, as I was telling you, a lot of inventory management and aspects. Can I manage the demand better so there is less stockouts? Let's say customer buys something and immediately you get a call back. Sorry, it has stocked out. Is it a good customer experience? No. With a good demand forecasting, you can avoid such situations. Visual search, if you go into the public sector, lot many such use cases. Smart cities, sustainable development, intelligent transportation, security aspects, or disaster recovery. There are too many things, from a public sector standpoint. Similarly, financial. They deal day in, day out with fraud analytics and risk analytics. A lot of transactions happening. How do I prevent some sort of a fraud? How I do a more personalization out there, that I give a good scheme or good particular option to my customers so that I'm able to convert them, or basically they are able to buy this. Media entertainment, very commonly with all our millennials out here. You're watching Netflix, Prime, multiple things. There's lot many happening there. You're searching by text, you are speaking and saying that I want to play this. You are doing a audio search. You are doing any sort of a translation into multiple different languages, getting subtitles being created. All of this now getting automated using ML. Manufacturing, again, a big space. You have supply lines, how I identify defects in a products. Can I convert from a manual person looking at a product and looking, oh, where are the defects, rather than there is a camera which is taking images and identifying, oh, there is a defect in the product, just put it into a different supply line. All this is happening today. In healthcare, then again, there are a lot many other use cases, risk prevention, clinical data. This is a different problem altogether. How do I convert from your x-rays or your reports that have been generated, health reports? And post-COVID, this has increased to a lot of, I would say, a lot of attention is being given and diverted towards healthcare problems. Now, what is a simple step? This is what I tell organizations, and this is what I tell teams, and I'm going to tell you also. 4 simple aspects that one has to look and build your data strategy or your AI strategy. First, create systems for scale. Okay, so don't think that, okay, I'm going to create a system which is going to solve my current problem. I don't think about if it is able to scale or not. No, you have to design systems which can handle the scale. Of course, you will not be able to look at, if I have megabytes today, I want to go for petabytes and I want to design the system for that. No, the system should be able to heal or scale on its own to from megabytes to gigabytes to terabytes, so that you don't have to again redesign the system and waste a lot of time. So think from a scale perspective. Think from performance perspective. Today, I am doing some things in a batch. Tomorrow, I want to convert this into real time. Just like I was saying, before you used to place the order in groceries and they used to just, okay, I will come back in a week, take all the orders, batch process it, and then finally, it used to be delivered in a week's time to you. It's 10 minutes now. Do you really think they're still working in batch? No, they are completely real time. So you have to think from a performance perspective, that what will happen if the data comes in a very large numbers, how I can act in real time, how can I act in a low latency. Third, addressing a problem does not mean you have to learn or add a lot of complexities. No, keep your system ease. It should be self-serviced. You don't have to have too much dependencies in order to arrive to your insights. It should have ease of use. So it should be well integrated. It should have self-service. The stakeholders should be able to themselves use the system. If I'm, as a data engineer, if I'm going to design a system which my users are not able to use, and they have always come to me and say that, can you get me a report? What is the use of that system? I'm then stopping all the innovation. They are not able to try, and I'm just I become the bottleneck. So you should design systems which can be easily adopted and used by the users, for which you have basically designed the system. And it should have API integration so that anyone can basically share this data also to the respective applications or stakeholders. And last, think from a future readiness perspective. And don't think these are something that is applicable to organizations which are very matured. All these things are even applicable to a fresher who is trying to build a small application. You should think about load. Whether it is able to handle scale. Let's say you are designing an application. I still remember when I was in college, I designed an application for online counseling. And I designed the complete system using Java, and there was struts at that particular point. We never thought of scale. We never thought that if there are going to be too many requests coming in, will my server be able to scale up to that level? We never thought of performance. We never thought of ease of use. We just created an application which we know we are going to click and do this, but was it easily used to be utilized by any other users? Nowadays, it matters a lot. So even if you are building a smaller application to a very large enterprise application, you have to think for scale. You have to think about performance, think about ease of use and future readiness. Can I go and build some innovation from it? Is it ready for AI/ML? The major reason why many AI/ML projects in production, they still fail. I work with many different large customers, digital natives on a daily basis. What they tell me is that this AI/ML is not working, or this particular algorithm is not working. The major source or cause for that is the data is not in the right format. Their system, the way they are recording the data, the way they are cleansing the data or processing the data is not in the right format, so you will not get good results. If you going to give water to a plant, is it going to give me fruits? No. So similarly, your data is the water to your AI. If you have the data right, if you have a good understanding of your data, if you organize the data well, that is going to get you better fruits when you're going to apply a machine learning in the top of it. So you have to have a system which is future ready in certain scenarios. When need comes, I can apply AI and I should be able to get insights. So last, how do you achieve it? You have data which could be from your first party organization, could be from outside. You use data analytics and AI to basically identify trends or any forecast, and basically give it to either your business users or your customer analytics users who are identifying customer patterns, their habits, many other things, or even for operational efficiency. Let's an example of a manufacturing customer who is looking to improve the operational efficiency, or a warehousing customer who has a large warehouse and they want to understand how I identify the products? How do I identify the right packages? They're not damaged. There could be multiple such use cases. Now, final last thing that as a developer, you need to understand, or as an engineer that you need to understand is, in order to have your journey or move from a journey of mobile apps, web apps, where your data is generated, which is your sources, to the extreme right, where you have analytics, business analysts, or the stakeholders who are basically identifying insights from the data. There are these 6 different stages that you have. Whether it's a data ingestion. How do you ingest the data? And there are many frameworks I have listed out here. If you want, you can take a photo or maybe a snapshot of this slide, which talks about few of the major, well-known frameworks on each and every stage, where you can either use one of them. Let's say Kafka is very well known for real-time streaming and streaming ingestion, or Apache Nifty or Apache Scoop for copying data from different data sources, be it SQL, NoSQL, and bring it to your HDFS. There is even Airbyte I've recently come across that provides a good way for ingesting data. It's open source at this point. So there's a lot of different frameworks which helps you ingest the data, bring the data into your data system. What is the next thing that you do? You basically prepare your data, or cleanse or transform your data, or process it using then certain frameworks like Apache Spark, very well known, easy to start with. Apache Beam, very new Google open source 5 years back, and it's been very widely adopted, unified way of processing your batch in real time. There is Flink, and if you don't want to go into a lot of code way of writing your pipelines, and if you say that, no, I don't have much coding background, you can go for certain solutions like Talent, K9. They have their community versions as well, where you can, in a UI way, create a pipeline and basically integrate your data sources and your storages, which is your data sink, the storage layer where your final data is going to land into. Now, that particular layer, depending upon different use cases that you have, it could land up in a SQL-based systems like MySQL, Postgres. It could even land up into a NoSQL databases. So very commonly being used out there is, let's say I want to store some sessions. I want to store user locations or some user metadata, and I want to very quickly read it. So then there is Redis, very commonly used by the community. Or let's say my application is only responsible for identifying the number of visitors on the website. I don't have to look into the details. I just want count aggregations or aggregated data, and I'm just dealing with that. Then Apache Druid is a very good framework for in-memory aggregations, where moment the data arrived, it automatically increments your counters or aggregations, and you can use that in real time to display on your websites. Mongo, a very good example of using your document databases, like where you have catalogs, you have blog websites, or you have gaming websites, and you have different metadata on your gaming websites. That all Mongo can be easily used for that kind of a storage. Relationships, friend of friends. When Facebook brought in that aspects, or Twitter has it, or there are a lot of social media. So they basically deal with relationships. I am a friend of another friend, which is a friend of friend. So all these relationships, how do you maintain it? Using graph databases like Neo4j is very popular one of them. So you can also go and try that. Now you have understood the data ingestion stage, data preparation and processing. There is a storage layer where you are keeping the processed data. How do I now start exploring my data? Do an exploratory analysis and do it in an easy manner. Jupyter, very widely used. It's a Jupyter notebooks, which not just allows you to integrate with your source systems, run queries or any analysis, but also visualize it within that. You have Matplotlib, Plotlib libraries. You have a lot of visualizations already available in Jupyter Notebook, which you can use to identify patterns in your data. And other alternatives are Google Colab. If you just want to focus on your BI dashboards, there are some open source variants that you can use. Grafana, very commonly used, D3.js, and even Google has one called Data Studio, which is free, where you can connect a lot of data sources and do an interactive analytics on the top of it. Now, let's say you have already explored the data, and I want to do a much more ingrained analytics in terms of big data analytics, large amount of data, distributed processing. What are the various frameworks that you can go and look at? One is Apache Trino. It is again properly known as Presto earlier. Now this is a new version of Presto called Trino, Apache Trino. This provides you a distributed in a SQL way how you can query your data warehouses or your data systems. Let's say your data is on HDFS and I want to query that. Just go and look into it if you want to further understand Apache Trino and how it works. And there's Apache Spark, of course, for doing any sort of Spark SQL, for doing any analysis. And if you don't want to go into, again, these are a little detailed systems, more code driven, you want to go for a wrapper systems, which give you easily plug and play plugins. And you can go for ClickHouse, very commonly used. Again, Delta, Apache Hudi, open source by Uber. See, these are some of the frameworks where you will have a lot of lot of plugins, a lot of already created pre-features. You don't have to create from the scratch and start using it. This is basically for distributed processing of your data. For either could be for using SQL, or it could be using code, or it could be using, depending upon what sort of aggregation that or use case that you want to solve. Last stage is machine learning. If you want to do machine learning. So first 3 stages is more of sequential. You ingest the data, you process it, and you store it. The rest of the stages are more of parallel in nature, just like I showed you in the previous slide. Either you could explore data using Jupyter notebooks and also use it for doing analytics. Either you can just do analytics on that directly on that particular data, or you can directly do machine learning on that data. Now, very popular machine learning frameworks I've listed out: TensorFlow, PyTorch. You can start with any single of them. And think of it, this is not a step-by-step process that I'm going to tell you. Wherever you have interest in, you can go and pick that stage. Nowadays, tutorials, sample data sets are easily available to you, Kaggle data sets, or there are a lot of public data sets. Even Google provides a lot of public data sets. You can simply go and start looking into a particular stage directly. I want to do a machine learning, go into TensorFlow, you will find a lot of data sets. It's just that my personal suggestion would be to first understand the steps around data processing, about what is the importance of data, how do you store it, and then you can immediately go and start with using machine learning and identifying what is the business problem I'm trying to solve. Am I looking at regression or forecasting? Am I looking at categorization? Am I looking at what we call as matrix factorization, which is similarities or recommendation systems? Or am I looking at time series analysis, like stock prices analysis? All of this depending upon, or it could be even unstructured data. I want to do an image processing. I want to do an audio processing. Or it could be an NLP, for example, that natural language processor. I want to convert maybe a one complete, let's say, article into a summary of that article. I want to create a summary of this entire big article. So there are multiple different algorithms for that. BERT and many other NLP algorithms. Hugging Face, I've heard of it. That's a very good framework to be used. So it gives you there are a lot of things within machine learning, depending upon, pick a use case and try and see which is be a right framework for that. And at the bottom, a lot of common way of programming all the stages is Python. So go and definitely learn Python. This is I would say a very important aspect. But if you do not have a coding background, Python is not that difficult. You can also go for another alternative like Java. That's also being used in many different frameworks like Spark, Kafka, and many other areas as well. And also something that you can have a look on, or you should try and learn, is JavaScript, because when it comes to using all this techniques for your application purposes, you want to create a custom application where I want to embed a dashboard or whatever analytics I've identified. I want to present it, and I want to create a very quickly some sort of a UI to it. So JavaScript becomes very handy. Even there are nowadays many of this big data or frameworks or libraries across different stages. They also support JavaScript as their source of language. So that's all I had for today. I hope I'm able to provide you with a good understanding in terms of what is data, how you deal with data, what is the importance, what different keywords it has, buzzwords, what is machine learning, how you can draw simple analogies to machine learning, what are the different types of machine learning and problems out there. And when you use both of them, what business problems you can solve, what different use cases you can solve, what different frameworks you can get started with, which will help you on that journey. So, Shubhang, I'll pass it over to you. I know I've taken a lot of time, but I have time. We can further extend it for questions.
So, thank you so much, sir, for such an engaging session. And I'm sure a lot of people who didn't even know about machine learning earlier are now probably going to try and get into this field, because, as everybody knows, this is the future and this is a very hot field to get into. So, sir, I will ask. There were a few common questions which a lot of people usually want to ask. So, I'll just ask them, and after that, the floor is open for questions. Anybody can ask. So the first most common question, sometimes even which I faced earlier when I was starting out, was there are just so many courses available on various platforms, like it is Coursera, Udemy, Analytics Vidya, and some popular courses to name is the Google Data Analytics course. It's a specialization. The Applied Data Science by IBM, and even IIT Madras has released a Masters in Data Science, if I'm not wrong. So with all these options available, how do we decide which course to do or not? And does any course have any advantage over the other course?
Okay, yeah, thank you so much for that question. And it's a very common question. So what I would suggest is, see, you don't have, any course would help, but your fundamental stages that they're going to cover will remain all the 6 stages that I talked about. Those courses are going to help you cover what are the different ingestion ways, platforms, libraries, what is the way you can process your data, what is the way you can visualize your data or store your data, what different ways. So just try and look into the course content. Is it covering these different topics? Is it talking about ingestion at scale? Is it talking about processing, distributed and non-distributed? Is it talking about storage at scale, high throughput storage? And at the same time, what are the various analytics options it is trying to teach you? Exploratory analysis using BI or machine learning. And there are specific courses that you would see on machine learning. So I would say no course is bad. Just go ahead, look at whether there are right elements in that course and just kind of attend it. Regarding the proper masters or degrees, I would first encourage you to have a basic understanding of these concepts with some of normal courses. And then if you see that, okay, there's a specific area, I want to go ahead and do masters. Like it could be possible, I want to do masters in statistics or data science. So I would have to definitely have more fundamental knowledge of mathematical equations, differentials, integrals, descent, and many other things. And then that would be the right way to go for the master's approach. Or I more want to be an ML engineer. So depending upon what kind of course you want to pursue, look for the right elements, build your foundational aspects, do hands-on practice using some of the tools I mentioned. You can have your own Jupyter notebooks. You can go to a cloud account and start practicing. They give you a lot of credits in the start. Quick Labs credits are being given out. Cloudera you have Coursera courses being available freely. So try and leverage information and look for these right elements that I've pointed to.
Thank you, sir. So the second question is, I think, more of a follow-up to the first one. So there are so many roles which are available, like you stated, data engineer, there is data analyst, there is data scientist, and then there is a machine learning engineer. So people get confused. What is the difference between these roles and the difference in the tech stack that is required for these roles? And how do we decide that which one is the right for us?
Yeah, very good question. So what we need to, before we kind of pursue any of this role, what we need to clearly understand is the roles and responsibilities of each role. Like I showed you the entire stages of data AI. So it's a very easily relatable. Data engineer role would be to make sure that you're able to build robust pipelines. What do you mean by that is you're able to create integrations from your data sources. You are able to look at the different functional requirements of scale, throughput, create some data storage systems, and then basically you are able to process the data at scale depending upon how much amount of data that you have and type of data. All of this is what data engineer is doing. Data analyst, on the other hand, is more responsible for the exploratory analysis or the operational or descriptive analytics. For example, I have data in my data warehouse. I want to run multiple SQL queries. So for them, important is to understand SQL. They are more responsible for identifying patterns, creating dashboards or reports out of it. For a data analyst, they don't have to understand the basics of data engineering, which are the sources. More they need to understand is what is the data, what features it has, what columns it has, how I can use these columns to generate certain patterns, what techniques, SQL techniques or aggregation techniques I should use in order to get better insights, and then how I can visualize this or present this to my key stakeholders. ML engineer, well, I'll not come into ML engineer. Data scientist is more responsible that I want to do analytics, but he's focused on predictive analytics. For him, data is already there. It may be in the raw format, or it's maybe in a cleans format. He is looking at what is the specific problem I'm trying to address. Am I dealing with structured data or unstructured data? Which particular business problem I'm solving? Is it recommendation? Is it demand forecasting? Is it price optimization? And depending upon those use cases, which is the right modeling technique, machine learning technique that I should use, which particular algorithm I should use. For him, more important is to focus on whether the data is in right shape, what features I should pick, how I tune my features, how I train my model, which algorithm, then how I improve the accuracy of my model. He's focused more on these aspects. And therefore, you need statistical knowledge to a certain extent, I would say, and more knowledge around the algorithms, the data cleaning, feature engineering, and those aspects. While the last, which is ML engineer, he is more responsible for operationalizing of your analytics. Now that could be a BI analytics. I want to operationalize the entire pipeline end to end. It could be on the data engineering. It could be building of the model, what all steps that a data scientist will go through, getting the data, converting it into a proper forms, picking up the features, doing iterations of over my model, using multiple different algorithms and conducting experiments, and finally deploying that model to be in production with API integrations. So this is the role and responsibility of a ML engineer, that right from the data to the model to the APIs, he's able to orchestrate this entire thing together. So this is the clear, and depending upon whichever role you want to go ahead, you will have to learn those foundational concepts. Just like I told you, data engineering, you have to look at data engineering concepts. Data analyst, then you have to look at data analyst concepts like SQL, like aggregation, visualization. If you're going for data scientist, then you will have to look at machine learning concepts, statistical concepts, the feature engineering, feature cleaning, and different stages that it involves. And when you're going for a machine learning engineer, you will have to look at DevOps part of it, operationalization part of it, how I do the API integrations, how do I do a complete decoupling of and there are different frameworks which are available for that.
Right, sir. Thank you. Another common question that rises is, which a lot of people have now asked also, that what are recruiters looking for in a resume for these job roles, and how important are projects? Because like you said, data sets are available open source. We just take any data set and somebody's already done an analysis on this and it's available on YouTube. So we are essentially just copying what is already done. So
Yes, sir.
how important are projects and how do we go about this?
Okay, sure. I would say a great question. When I was in your shoes, this was also on my mind as what is the recruiter looking at? And this is really hard to predict. But I'll just tell you some of the important things that you should keep note of, okay? See, certifications do matter, but only at a certain stage. What is mostly recruiters looking at is three things. I also be a part of the recruitment team, and what we look at is, one, the knowledge. How much conceptual knowledge a candidate has, and that will never come from just by having certificates. It will basically come from when you do some sort of a hands-on. So one is the conceptual knowledge. The second we look at is the approach. Are you able to think from a business perspective that this particular technique or this particular things that I have learned, coding, data engineering, machine learning, what problem it is going to solve? So that is your approach to a business problem. If there are already data sets available, if there are already machine learning algorithms and code available, can you go and think out of the box? How do I apply a different technique to this? Can I use a different data set? Can I merge this data set or complement this data set with any other? Let's say I'm solving a problem. There is already a problem of weather forecasting. There is a weather data available. Can I also go and have a location specific data, the population data, how much density of data or population that I have, any other data set that I can identify and solve the problem or different modeling technique? That's the approach. And that can only, you can build again with more hands-on that you. The third thing that we normally look at is how, what sort of, experience the candidate brings up, what projects they have done in the past. So that is the third aspect that do add importance. If you have done some certification, it is going to at a high level help recruiter prune and pick folks like, okay, they have done some certification, but one or two is good enough. If they have created some projects in the past, that is helps me to screen a candidate. But moment the recruiter looks at or starts working rounds by rounds, we are more looking at your conceptual knowledge and your approach to a business problem, which will only come with when you have hands-ons and you try and think out of the box, try and add iterations to something which is already available, because that will not only help you, and don't get scared from failing. Of course, whosoever has created these machine learning problems, they may not have succeeded in this first, but while doing this, you will learn a lot of techniques. You will learn a lot of nitty-gritties around it, which you can of course tell a recruiter in your experience when they are asking you questions.
Thank you, sir. We will take everybody's question, guys. Just have patience. There are 2 or 3 common questions which, if we can answer, then if sir can answer, then you guys won't have to repeat them again. So, sir, another common question is that a lot of people from core branches are now looking towards this field, and especially people from mechanical, civil, or any other branch, environmental, they might not like coding in the first place, or they are not very familiar with coding. So how important is coding itself for getting? We have seen that there are software such as Tableau or any other software, Power BI, which enables you to do quite in-depth analysis without writing a single piece of code.
You're absolutely right, and this is a question that definitely would resonate to many folks out here. See, so very important that you have to look at is the question that when I answered and clearly separated out the responsibilities of different personas, data engineer versus data analyst, or ML engineer versus data scientist. You have to look at one, the roles and responsibilities of the user, and second, the job responsibilities for which you are going to pursue. If you are going to pursue for analyst role, you may not need a coding background. What you need more importantly is a SQL background. But that does not mean that one who does not have a coding background has to go only for data analyst. They can still go for ML, because ML would not even require coding at the first. It will require your mathematical knowledge. You need to understand what are the basics behind machine learning. There is descent, gradient descent, boosting. There are many different techniques, and all is based on mathematics, which I think all of the engineers are well equipped with. So first, try and understand what is the roles and responsibility of a particular role that you want to pursue, what is needed, and based on that, what is the job responsibility or requirements your recruiters are asking for. If they say that I want to go for ML, I'm hiring an intern for data science, and they should all know Python or R or any of the language, then you would have to need. But if they're hiring for a data analyst intern and they need that, I need a person who has SQL basics, who have used MySQL or who have used any of the SQL and they know how to write SQL, they know how to do filters, they want to know how to do aggregations and different other UDFs if required. So then you would have to learn those aspects. But given that it's not that coding is must for these roles, no. If I look at even an ML engineer, they will require some set of coding, but now there are more templatized frameworks available like Terraform, Ansible. They have YAML based, there is very less coding that you have to write. They are more focused on API integrations. They are more working on HTTP, HTTPS, REST integrations, gRPC integrations. So there are a lot many things out there apart from just the plain simple coding. But yes, for data engineer and for data engineer, definitely these frameworks would require you to write code. For some data science also, because for application use cases you need to have coding backgrounds, then you should go for Python or any other programming language.
Right, sir. And sir, I think one of the most sought after question now is that your journey to Google, how to get into Google, and your own experiences from the journey. What were your learnings, and finally after being in Google, how should other people follow a career path so that they can also get into the tech company of their choice?
Yeah, sure. See, first of all, do not have a scare or fear in front of you that getting into Google is very difficult. No, I also come from I would say a tier 2 college in Delhi. But one thing that when I was in college, two things that I focused on. One was my coding skills and my communication skills, both. Okay, so which is fine. It's not like always one has to go for that, but this is what I followed the approach, is that I want to be an engineer, I want to go into coding. So I basically, when I started in 2010, I was a full stack developer. I started with even Flash programming. So there used to be a language called Flex. We used to create Flash programming, and there used to be frameworks around it. And then I learned Java. Then I learned. So I already did Java projects during my college days. I created multiple different projects on Java, but mostly all of them were related to applications, web applications. And then I learned multiple different other languages as I approached. In the first 3 years, majorly first 2-3 years, very few data projects that I was able to do, but I did mostly application projects. But that gave me an understanding of how systems are built from top to bottom, how data basically flows from an application, because there you're more focused on, if a transaction is happening, if someone buys something, the data entry should happen. There should be CRUD, create, read, update, delete. How do you handle transactions? That give you a lot of understanding around execution of data. And then I started to work on big data projects, like understanding what is Hadoop and other different things. And then my second organization, I was completely exposed to working with big data. They used to have large amounts of data available to them, and we used to write MapReduce and many other different techniques using Hive and many other frameworks. So overall, if you look at, and then I went on into another company where I was leading the data center of excellence, building data lakes, which is Astro, and finally got into Google, where I'm right now working as a technical customer engineer, but I'm specializing on data. So I basically work day in, day out with multiple different customers. So if you look at what helped me getting into Google was, first of all, the conceptual knowledge that I gained. And that can only come when you have more hands-on practice. Okay, and does not mean it has to be an enterprise level problem. It can be a simple problem. Data sets are available. You can, even if you're building a smaller problem compared to a larger problem, of course, you will with the larger complex problem, you will face more, get better, higher experience in facing the complexities, but you need to have a basic conceptual knowledge. Second, I worked on my communication aspects, which has helped me in looking at the business problem. We are not, a company is not hiring an engineer, be it Google, Microsoft, just to write the code. They are hiring you to solve a problem. And in order to do that, you have to bring that thinking in your mind, that how do I approach a problem before even writing the code? What are the different steps to approach a problem? What is the problem statement about? how I'm going to address it. And then we start looking at the code, or where to basically implement those specific steps. So these two things I would suggest every one of you to inculcate as you go forward, be it you're a fresher, be it you're in third year, be it you've already got a placement and you're going ahead. Try and keep your conception knowledge, keep your hands-on knowledge, and try and practicing as much as possible, and look at business problems. If someone says me that you have to go and build a demand forecasting, what all it will require? I have to think from all different aspects. Where is the catalog coming from? Where is the inventory coming from? What is the supply chain? What is the delivery model? What is happening, and how different integrations are happening? Now, what is my previous data? What is how much improvement I'm looking at? So we have to look from all different aspects and then design the problem. And that's where Google and companies like Google stresses a lot. How do you design a solution? How do you approach a business problem?
Thank you, sir. I think that is a very important statement, that they are hiring you not just to write a piece of code, but to solve a problem. We have to look at the bigger picture here.
Yes.
Okay. So finally, guys, the floor is open to your questions, and I see a lot of them have been written in the chat box. So I think let's start with Parth. Is Parth there? Go ahead, Parth.
Yes, I'm here. First of all, thank you so much. It was such an informative session. We actually had a look from an industry point of view. You brought a very interesting point, which is graphical data sets. I have worked with some of them, and they give very, very powerful solutions to recommender systems and even natural language processing. So how can we as aspiring data scientists actually start working on our own graphical data sets?
Okay, so see, the easiest way to approach this is first get your, pick a tool. If you're already well versed with Python, or you want to do a Jupyter notebooks, then what you start doing is look for different data sets. Okay, it could be Kaggle, it could be multiple different other data sets. First, identifying a problem, rather than identifying a problem, just do some exploratory analysis yourself. Okay, maybe using different matplotlib or different library. Try and identify, what is the distribution of my data. Look at different types of distribution. Is it discrete? It is uniform? It is continuous data with a time series data. Look for different types of data and try and visualize it in a different distributions manner. Just look for it. There is multiple different types of distribution. There's Poisson distribution. There is gradient distribution. So and look at from that perspective. And then I would really suggest you go for get enrolled to any of the data science course. I always found, if I remember, one I started with was Andrew Ng's course on data science, a very good foundational one, but there are a lot many available nowadays. And they will take you, what good part that gives you is the overall, what is the agenda or what sort of a timeline you have to follow. First, they will make you understand, okay, what are the important aspects when you do an exploratory analysis? How do you visualize the data? How do you look at the different distributions? How different distributions help you identify insights out of it? Where is my anomalies happening? And then basically you start looking at a business problem. Okay, someone is trying to say that I want to identify the COVID patients in a particular location. What is the density? I can go and plot all of this data. COVID data is also very easily available, and plot it into a graph and look at using a simple scatter plot graph. I can look at what is the density of COVID patients in a particular location. So try and look for business problems around you. First, get some foundational aspects, get different ways of visualization, distributions, and how do you plot the data, and then look for applying it to business problems.
Thank you, sir.
Right. Then I think we can move on to Shoaib. Shoaib can ask his question.
Hello, sir. Sir, my question is: having a good knowledge of data structure help you to crack the data science interview? And my second is, what would you prefer more, a good rank or on Kaggle, or a good project made on GitHub from interview point of view?
Okay, so for the first question, see, any knowledge is good. So having a knowledge of data structures definitely help you give a perspective in terms of what kind of storage options I want to use. So if you look at, when I talk about these frameworks, these databases, they all use these data structures at the back end. They are using linked lists, they are using trees, they are using different ways like indexes in databases, they use B plus trees. So all these data structures will definitely give you a foundational aspect. But is it mandatory? Not at this point. But any extra knowledge is never harmful. Okay, so it will help you one day or another. Second, see, for me, getting a rank or versus this, it's not a versus any a time. It is how do you, it's a simple trade-off, okay? How do you balance out things? So doing more projects will give you hands-on, getting good rank, or let's say, will give you that minimum qualification and the conceptual aspects that a recruiter will be looking. So it's like both or all of these things are important. You have to balance it out. If you want to go, if you are able to get the conceptual knowledge and a fair rank, but more hands-on by doing projects, then of course you have good chances of clearing it out, because one, you have gained the hands-on knowledge, you have the conceptual knowledge, you have the minimum qualifications met, and by doing projects, you are looking at business problems. So you have inculcated that mindset also of approaching a problem. So all of this is going to help. Which is better one over another? There is no simple answer to that.
Okay.
Thank you. Can we now have Atif? Atif, are you here? I think he had some internet issues. He just left the meeting. I'll read out his question. So this question is, I'm learning C++, but as you said, we have to learn Java, Python, etc. So will I have to learn these other languages too?
Not necessary. C++ gives you a good understanding of the object-oriented aspects of a programming language. It's just that, again, just like I said earlier, a particular requirement of a job that you would be pursuing, what role you would be pursuing. If you are going to pursue a data engineer role at this point of time, C++ is okay, but the moment you will start using some frameworks, they have their own predefined languages. Like if I want to go for Spark, it is available in Scala, Java, Python, and Go. So I will have to look for a language which I can use it. If I want to go for a SQL kind of things or analyst, I may not require any knowledge of the programming to a larger extent. But if you want to go for a data science role, most of them would require either having a Python or Java or any sort of R that are most required. So you will have to anyways go for any of these programming languages, depending upon what role do you see yourself in.
Right, so thank you. Yash had asked a question, any tips to get into Google? Is that answered, Yash, or do you want sir to answer once more? Sir, I think you explained it. I mean,
there's nothing additional that I would say. All of the companies, be it Google, Microsoft, anyone, what they are looking at, as I said, one is your algorithmic skills, your how you approach the problem, how you break down the problem into smaller aspects, and then implement solutions for that. Some basic knowledge of data structures, some basic knowledge of frameworks or projects or any sort of and more hands-on you are, the better clarity you will have in your mind, because you will always say that I have implemented something or other related to this kind of a problem, so there are different techniques when you approach a problem. It's not like one fit technique. That, let's say if I want to approach a problem of parking lot, very common one. There are multiple ways. Some use queues, some might be using stacks, some might be using different sorting algorithms for approaching that. So there could be different techniques. If you have practiced one or two techniques, that will give you some clarity and confidence to approach a problem. So they are not looking for the right answer. To be very honest, you will hear this from all different areas and blogs and leaders who have cracked these companies, is they are not looking for exact right answer. They are looking for your approach to a business problem. If you are stuck, how you think of different alternatives. Your alternatives may not be the best, but are you able to think from that perspective? Can I go and reduce my time complexity? Can I go and reduce my space complexity? How can I do that? Can I use arrays instead of using some list? Can I use some graphs instead? So I'm talking about very basic things. But moment it comes to a little more complex problems, how this together you can approach. So ultimately, your knowledge, your hands-on, and your approach, how do you break down the problem? That what matters, rather than the exact right solution.
Absolutely. And sir, the next question is by Utkarsh. Utkarsh, do you want to ask your question if you're there in the meet?
Yeah, first of all, thank you for such a wonderful session. And my question is, a lot of people suggested me that big MNCs like Microsoft and Google, they ask for a postgraduate degree or even sometimes PhD for the role of machine learning engineer. So is it true or just
See, I would not like to comment on that. See, it all some of prerequisites are there for any other for specific things. Even today, no one is stopping you. Go to careers.google.com, search for a particular job, and you will see all the prerequisites mentioned out there. Some will say that you just need a graduate with some experience. Some will say that we don't need an experience. Some will clearly say that we require a PhD. So don't assume anything. Go into careers.google.com or similarly career websites of other companies. They have outlisted very clearly what is their minimum requirement. And accordingly, you will have to pursue. And this is really good because at your point of time, we were really not thinking what is the entry criteria for those companies. We were just thinking over, oh, I want to get a placement done. But now things are more clear, things are more available, it is more transparent. So you know that if someone needs a PhD degree or a master's degree, and this is where my interest lies, then I should not be spending too much time in looking for the placements, but rather than going for the masters.
okay? Thank you so much.
Thank you, sir. Thank you for your time. There are no more questions. So the session got slightly extended, but it was. I hope everybody got to learn a lot from this, and your doubts, most of them are cleared. So thank you so much, sir. Again, thank you for.
Thank you.
Thanks a lot, sir. Thanks a lot, sir. It was really helpful, sir.
Thank you so much. There's one question. I think Abhishek just raised your hand.
Abhishek raised his hand.
Yes, sir, I'm saying that I'm a student of mathematics and computing, but some students say कि top MNC companies like Google, Microsoft वो require computer science student more preferably. It is true.
No, I don't think so. That's true. So with using mathematics and computing, definitely you have a very good scope of going into data science, statistical areas. I don't see that's any sort of a hindrance to getting into these companies. It's just that, of course, you will have to
Okay, thank you, sir.
get your knowledge in place, do some hands-on, do some projects, learn things, learn a programming language would be required. But I think that's maths and computing is really important. Nowadays, you would see a lot of areas which are in their high paying as well, more than what the data engineers are fetching a data, but they are less in number compared to, of course, the data engineers. But data science require a very good knowledge of mathematics, probability, statistics. You can become a data science. I have seen data engineers becoming a data science. I will never call myself as a data scientist because I still feel I don't have the knowledge, complete knowledge of statistics. I know I have the knowledge of applying machine learning, but how to build a model, how to sort of increase the accuracies of the model, how to understand how the model is working beneath, that you can only understand if you have computing knowledge or mathematics knowledge.
Thank you, sir. We have another question by Kamal, and then Yash, I'll come to you after that.
So I have a similar question. Like I am from engineering, physics, like not in computing subject, but I also wanted to get into in tech companies, like do something in tech.
Yeah, so see, tech companies, you will not see too much of specific restrictions. I'm not sure about certain companies. You would see they are asking for more of a graduation or post graduation. If you use having computing, mathematics, I don't see that's a. Some companies may or may not have it, but very important for you to understand is the journey in front of you. Okay, how do you convert your journey into more application based, problem based, and learn things while you go ahead. And when you basically go for those interviews, which I would not say too many companies are asking for that criteria of they used to be earlier, but I don't see right now there are too many restrictions in terms of which stream that one comes from.
Okay, so thank you.
Thank you, sir. And finally, Yash had the question. I think it was a similar question. He said that for learning ML and AI, do we need to learn DSA in Python, or can we directly move into ML or AI after learning the basics?
See, as I said again, you go ahead. You want to do that. More knowledge is never bad. If you feel that you have, but don't restrict yourself. If you feel that right now I don't want to spend too much time on DSA and I want to go and look at the application of machine learning, go ahead, learn. But it's always you can come back to that. Tomorrow, if I understand, okay, I know how to apply a regression, but I don't know what sort of optimizations it is using at the backend, and I want to understand how does it optimizes the space, how does it optimizes the time, how. And moment you reach there, then you can go back and look at data structures and DSA and other things, how this is going to help me optimize this business problem or this technical problem. So there is no such entry criteria that you should always have this and then go for it. No, you can always come back, but extra knowledge is never harmful.
Thank you, sir. Does anybody have any other questions? Right. All right. So thank you so much for joining. And we have the second day as well of the data science workshop. So I hope all of you will be joining. Tomorrow we'll be having a hands-on Python and Jupyter notebook working along with a short ML introduction as well. So I hope to see all of you tomorrow as well. Thank you so much.
Okay. Thanks everyone. Have a nice
you,
day.
sir.
And good luck.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Thank you so much, sir.
Guys, we'll be sharing a feedback form soon on the group. So please fill that out and we'll see you tomorrow then. Thank you.